right, the last information about angles. We talked about 3 other situations. We've got our central angles, where we have our angle and our intercepted arc, and we found out when the vertex is at the center, the angle is equal to the arc. Then we talked about when the vertex is on the circle. Now it can look like that, or it could look like this. But if the vertex is on the circle, then the angle is equal to half the arc. The angle is equal to half the arc. Okay, and then the last one that we talked about said, what happens if it's outside? Well, we had several different situations, but basically it all comes down to the same rule, that the angle, right here, we cover up the angle, and then we look, and it hits those 2 arcs. Those are inscribed or intercepted, they're in between. That, let's call this M and N so that we have something to refer to. It's the angle. Since you have 2 of them, you need to subtract them. That the angle is equal to half of the difference between the arcs, the big arc minus the small arc. So those are the 3 situations that we've talked about so far. So we're going to add the 4th situation. Now, on this one, notice that I have these chords that cross inside, and they form this angle right here. Well, what I know is that this angle is the exact same size because those are vertical angles. Now, notice that on this side that has the X, this side intercepts M. Then on the other side, the same angle intercepts N. So the problem is I have 2 arcs, and what am I going to do with both of them? Well, in this case, you're going to add them. Before I subtracted them, now they're adding. So one way that you can remember it is this kind of looks like a plus sign inside there, so that tells me I need to add them. So let's look. We've got angle 1. Here I'm going to trace. There's angle 1, and that's also angle 1. Let me put a little 1 over here so we can see it. And that's not an angle measure, that's just an angle name. So on this side, it intersects the 120-degree arc, and on this side, it intercepts the 98-degree arc. So because it is inside, the vertex of the angle is inside the circle, then I'm going to add the 2 arcs together. So it's half of 120 plus 98. So 120 plus 98 is 218, and 218 divided by 2 is 109. So angle 1 is 109. So that angle right there is 109. Now, number 2 is very similar to that, but notice that this time I'm asking for angle 1. Well, I don't have anything for angle 1. What I have is I have 53 and 41, and that goes with this angle. Well, what I do know is that those 2 angles right here form a linear pair. So let me call this one angle 2. Let me find angle 2, and then I'll go find angle 1. Well, this is inside. The vertex of the angle is inside, which means I add. So I need half of 53 plus 41. So 53 plus 41 is 94, and 94 divided by 2 is 47. So that means this angle is 47. So is that one. That angle is 47. But I asked for angle 1. Well, angle 1 and 47 add up to 180 because they're a linear pair, which means that angle 1, if I take 180, subtract 47, I get that the other angle is 133 degrees. So angle 1 is 133 degrees. Okay, so let's look. This one gets a little more confusing, but it's okay. We're just going to use the equation, right? So those are the angles that go with these arcs. So we find it, the vertex is inside. So here's what I know. The angle is equal to half of m plus n. The angle, which is x, and then we'll call this m and n, it doesn't matter. Okay, so the angle, which is 70, is equal to half of m, which is the arc, plus the other arc. So you have several ways that you can handle this. I think the easiest is let's multiply this side by 2 and get 140. So those 2 arcs together should add up to 140. So you want to double your angle, and those two arcs should add up to 140. So you take 140, and now we subtract 75, and we get that n is 65. So SN, or n, is 65. Okay, number 4. If you look, I want this angle right here is 55. This angle over here intercepts this 185. The vertex of the angle is inside. That means I'm going to take half the angle, B, is half of the arc plus the arc. You have to pay attention to which pieces you have. Do you have the angles or do you have the arcs? So 55 plus 185 is 240. Divide that by 2, and you get that angle B, or UBE. Angle B, in fact, let's be proper. Let's call it angle UBE is equal to 120 degrees. That's this angle, which was the question mark. We could call it X if we wanted to, too. Okay, so 5, notice I have an angle and I have an arc. So we need to know what this one is. Well, remember, the angle is equal to half the sum. Okay, the angle is equal to half the sum. So the angle is equal to half of, let's call this X, X plus 130. Easiest way to handle that too is to pull it over here. Let's do 210 is equal to X plus 130. So those two arcs, this arc and this arc, should add up to double the angle. So I'll take 210 and subtract 130, and I find out that X, or that piece that I was looking for, is 80 degrees. Now in 6, again, in 6 I have the two arcs. Well, that makes it easy, because then here's my two arcs, here's my two angles, and that's what I'm looking for, is the angle. So I'm going to call that X. Well, I have my two arcs. The angle is equal to half the sum of the arcs. So 85 plus 65 is 150. Divide that by 2, and you get 75 degrees. So that angle is 75. And see, so if you double it, right, 75 and 75 is 150, 85 and 65 is 150, so they add up. So now we have all 4 situations: when our vertex is in the center, when our vertex is on, when our vertex is outside, like right here, and when our vertex is inside. So what you really have to do is pay attention to, when they're all mixed up, where is the vertex of that angle? Take the time to highlight the sides and highlight the arcs so that you can figure out which